Hello everyone. So I'm back with one more video. So basically continuation video of the numbers topic. This is the third video in the sequence. So today we are going to cover a few more topics pertaining to the factors concept. So in the previous video, second video, we have started off with prime factorization. What is the use of it? We looked at how do we calculate number of factors and how do we calculate number of ways of writing a given number as product of two factors. So in today's video, we will be discussing few more concepts. So that you get access to all the videos, you get notification whenever a new video is uploaded, please ensure that you subscribe to our channel, YouTube channel, and do hit the bell icon, because whenever we will be uploading a video, new video which would happen in a matter of few days, sometimes in a week, right, you would get all the videos in line, right. And there are several other videos that we have already uploaded on both CAT level questions and also some other concept discussions which are there for other topics also. For example, geometry, for example, time, speed, distance, you can also check them out. Let's get started with today's class. So in today's class, we'll look at few more points pertaining to factors. Like previous class we have seen number of factors, number of ways. Let's now look at the next point, which is how can we find product of factors of given number n. Now by the way, just to recap, what is n? N in prime factorized form looks like this: a to the power p into b to the power q into c to the power r, and so on. So for this n, we have seen already in the previous video, number of factors will be given as and so on, and number of ways also the formula was f by 2, f plus or minus 1 by 2 depending on different cases. So what will be number of factors? Let's try to understand this using an example. Say if I take a number like 80, for example, 80 prime factorization is 2 power 4 into 5 power 1. So number of factors will be 4 plus 1 5 into 1 plus 1 2, which is 10. So overall we may say there are 10 factors. What are those 10 factors? The factors are 1, 2, 4, then you will get 5, then you will get 8, then you will get 10, then you will get 16, then you will get 20, 40 and 80. So as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 factors overall. Now the question is, how do we find product of all these factors? So what is going to be product of all these factors? If you remember in the previous class also we have checked this point, we have observed this point, that when you multiply the first number and the last number, you get the number itself. When you multiply the second number and second last number, you will get the number itself. When you will multiply the third number and the third last number, you will get the number itself, and similarly fourth and fourth last, fifth and fifth last. So can I say if there are 10 factors overall, there will be 5 pairs of factors whose product is going to be the number itself, and each of the product is going to be the number itself, right, the number only. So thus can I say when you multiply all of them, you will get the number itself, which is 80, 5 times. Can we say this? So when you multiply all of them, 1 into 80 is 80 power 1, 2 into 40 is 1 more 80, 4 into 20 is 1 more 80, 5, 16, 8, 10 are all 80. So thus can I say 80 will come 5 times. So thus my product of factors is going to be 80 to the power 5 is what we can note. Now can we have a formula for this? The answer is yes, we can definitely have a formula. The formula will be like, so product of factors, so let's say write Pf of n will be given as the number itself n to the power f by 2, where f is the number of factors. So even if n is a perfect square or not, this thing will absolutely work fine. You can take an example of perfect square also. So say for example, I take a number like 64. So what will be factors for it? 1, 2, 4, 8, 16, 32, 64. So number of factors that we get is 7. So when you multiply all of them, what do we get? We get 1 into 64, 164. So product of factors. Two into 32, one more 64. 4 into 16, one more 64. So 64 cube into 8. And 8 is what? 64 power 1 by 2. So what is 64 cube into 64 power 1 by 2? 64 to the power 3 plus 1 by 2, which is 7 by 2. Yes. So what is the 7 number of factors? So even if the number is a perfect square, the formula will work absolutely fine. So this is one more formula that we have that we should know in case of factors, which is product of factors of the given number n. Next, let's take a small example. So basically this example would involve all the previous concepts that we have covered so far in the video series. So let's say the question is something like this: if product of two numbers is equal to, 1,92,000, okay, find the number of possible pairs of numbers. How many such pairs of numbers are possible whose product is 1,92,000? So let's look at the solution. But before I start discussing it, you can just pause the video, try out this problem yourself, see if you are able to answer it yourself or not, and then you can of course watch the video. So if I take the number n to be 1,92,000, so can I write it as 192 into 1000? 1000 is 10 cube. 192 is 64 into 3. 10 cube is 2 cube into 5 cube. So this will become 2 power 9, 3 power 1 into 5 cube. So this is a prime factorized form of the given number n. Now once we have that, what will be number of factors for this, by the way? So number of factors will be 9 plus 1, 10 into 2 into 4, which will be what? 80. So there are 80 factors that this large number has. Now if there are 80 factors, in how many ways can we write this as product of two factors, two numbers? Now by the way, when I say numbers here in this context, I mean natural numbers. Okay, I mean natural numbers. Generally this is how the question would be asked, right? If product of two numbers is equal to 1,92,000, find the number of possible pairs of numbers. So in how many ways can we write 1,92,000 as product of two factors or two numbers, natural numbers? Can I say it will be, since this is not a perfect square, I see an odd power here. So thus can I say my answer is going to be f by 2. This formula was discussed in the previous class. So my answer will be 80 by 2, which happens to be 40 ways, right? However, please note the following. Had the question been, if A into B is 1,92,000, okay, same number, find number of possible A comma B, number of possible pairs A comma B. So how would this vary? The answer for this vary. So here also 1,92,000 is still the same, 2 power 9, 3 power 1 into 5 cube. Still the number of factors is same, 80, same, everything is same. And hence can I say my answer will be f by 2 only. However, here comes a major difference. Please pay close attention to this. Here, when the question was if product of two numbers is this. So for example, if I tell you in how many ways can we write 6 as product of two numbers, you would say only 2, right? 1 into 6 is 6, 2 into 3 is 6. That's it, only 2 ways. Whereas, if I tell you A into B is equal to 6, where A and B are natural numbers, here also A and B are natural numbers only, right? What will be the number of solutions for A comma B? So solutions will be 1 and 6 or 6 and 1. Please note, when the variables are mentioned in the problem, A equal to 1, B equal to 6 is different from A equal to 6 and B equal to 1. Here 1 and 6, 6 and 1 are taken as only one case, because here the distinction in variables is not there. Both are the same variables for us, there is no A, no B. Here we have distinct variables, so thus ordered pairs will be taken. So for example, 1 comma 6 is there, 6 comma 1 will also be there, 2 comma 3 is there, 3 comma 2 will also be there, and hence my answer here will be doubled. So thus my answer will be equal to number of factors, which is 18. So please note this small difference that we have in case of this problem. I hope we are clear with this. So we have looked at product of factors, a small problem. Now let us look at the next point, which is sum of factors. Sum of factors, how do we find it? So we will take an example for this also. So let us take a number. So if I take n to be 100, let us say 50 suppose. So we want to find sum of factors of 150. So by the way, what will be factors of 150? 1, 2, 3, prime factorization firstly. One plus 1, 2 into 2 into 3, which is 12 factors. Now what are the 12 factors? 1, 2, 3, 5 is there, 6 is there, right? 7, 8, 9, 10 is there. Then you get 15, then you get 25, then you get 30, 50, 75 and 150. These are all the 12 factors that we have. Now, we are trying to find sum of factors. So simply the answer will be sum of all these. When you add them all, what do we get? 150 and 75 is 225, 275, 305, 330, 345, 355, 361, 366, 369, 371 and 372. After this tedious process of adding them up, actually we get the answer as 372. Now can there be an alternate way, a better way of getting to the answer or not? Let us try to understand. Please notice, what will be the possible factors of 2 power 1? So it's only 2 power 0, 2 power 1, right? For 3 power 1, 3 power 0, 3 power 1, that's it. 5 power 2, 5 power 0, 5 power 1, 5 power 2, right? Please notice what happens when I add up these possibilities. Possibilities for 2, possibilities for 3, possibilities for 5 when I add them up. Now please note what happens further when I open up the brackets. Let us see what happens. So when I open this up, so 2 power 0 into 3 power 0, 2 power 0 into 3 power 1, 2 power 1 into 3 power 0, 2 power 1 into 3 power 1, right? Into further 5 power 0, 5 power 1, 5 power 2, okay? Let me write the continuation, the simplification part here further. So it's going to be 2 power 0, 3 power 0, 5 power 0 plus 2 power 0, 3 power 0, 5 power 1 plus 2 power 0, 3 power 0, 5 square. Similarly, the second term 2 power 0, 3 power 1, 5 power 0, 2 power 0, 5 square. Similarly, third term 2 power 1, 3 power 0, okay. So 2 power 1, 3 power 0, sorry, 3 power 0. And last term 2 power 1, 3 power 1, 5 power 0, 2 power 1, 3 power 1, 5 power 1, 2 power 1, 3 power 1, 5 power 2. So when I open up all the brackets, this is what I get. And please note, what are these equal to respectively? What is this? This is 1. What is this? This is 5, right? What is this? This is 25. What is this? This is 3. What is this? This is 15. What is this? This is 75. This is 2. This is 10. And this is 50. 25, 50. What is this? This is 6. This is 30. And this is 150. So if you notice, when you open up the brackets, you are basically getting sum of factors only. So a better way to identify or find out sum of factors will be for n. So sum of factors of n, where n was this, n was that, will be equal to, for a power p, what will be the sum of possibilities? A power 0, 1, a power 1 a square a power b into, for b power q what will be sum of factors? 1 b square b power q, and likewise for c power r and so on. This is going to give us the sum of factors, which can be further simplified now. If you are comfortable with geometric progression and all, you can further simplify this as, this is nothing but a GP which has p plus 1 terms, common ratio of a, so the formula is a to the power p plus 1 minus 1 by a minus 1 into, this will be b to the power q plus 1 minus 1 by b minus 1, and similarly for c and so on. So, sum of factors can also be remembered like this if you are comfortable with GP. If not, you can simply add up the possibilities, multiply all of them together, still it will give you the answer. Because see, the numbers are generally not going to be that large. So, it would be like perhaps 2 cube or maybe 3 cube type of numbers. Very rarely you will get to see 2 power 9 type of numbers and all, right, wherein it will be very hard for us to actually find the sum. So, this is how you find the sum of factors. So, in this class, in this particular video, these are the couple of points I wanted to discuss. Now, in the future classes, we shall be looking at some more concepts pertaining to factors, pertaining to co-primes, right. That is what we will do in the next couple of classes. So, again just to remind you all, so if you want to watch more content, more videos like this, right, please do subscribe to our channel. Please give in your inputs also, right. Okay, what topics would you like us to cover, right, so that we can have a plan for that also. On that note, let me end the session here. Thank you and all the very best.